Okay, so let's see here. I can write this set as A equal to F O L W, isn't it? I can write this one as F L O W. I can write this one as C is equals to F L O W. So if you're looking at all this set of elements over here, they have same elements, right? So I can write here A comma B comma C have same elements. Hence I can also say that A, B, C are equal sets. So this is your A, right? So let's look at the next one. You need to say that if it is equivalent to your or not equal to your set. Okay. So let us look at the first one here. A, B, C, 1, 2, 3, right? The first three natural numbers, hence it is equal. If you're looking at A and if you're looking at E, 1, 2, 3, you are having a set of numbers and here you have ovals. No. Let us at number C and D, A, B, C, D, A, B, C, D. Since you are having same set of elements, it is equal. Okay. Look at it. D, it is a set of vowels in English alphabet. You are having consonants also in your D. No. Look at A. These are your alphabets in F and you have numbers in A. No. If you look at it, D and E, no. Because the C is facing over in E. So if you look at F, it's a set of vowels alphabet, and if you look at B, no. You have the numbers in this one. So this is your answer of this way. So let's look at the next one. State whether A is equals to B or not. Okay, you need to say that if it is equal or not. Yes, you have same numbers. Is 8 repeated? Yes. 4 repeated? Yes. 12 is not repeated, hence it is not equal. Also two even integers less than this one, hence it is equal. Right? He said less than and here, right? So let me write it here. The LHS you are having both values of 1 and n, right? But the condition is x is greater than 1 and x should be less than n is the rule required to that. Okay. So similarly, let's look at this second one also. If you are looking at the RHS, when I am looking at the RHS, okay, when I am looking at the RHS, I have the condition that x is given plus 1. Right. His definition of it is the rule of odd numbers. How do I say that it is the definition of odd numbers? Because whenever you are adding something here, that becomes your odd numbers. Okay. Now LHS, what is the definition of the LHS? If you look at the LHS over here, right, all of them are even numbers. Okay. All are even numbers. Hence it is not equal. And let's look at the third bit. So looking at the third bit, if you look at if you look at the LHS, when I am saying at the LHS, it is a multiple of which table? Fifth table. When I do this, I'll get here 5 into 1. I'll be having a 5 into 3. I have here 5 into 6. I'm having a 5 into 9. Right? But over here in the RHS, he says that it is a multiple of 15. Multiple of 15. Okay. It is wrong. So let us look at the fourth one. When I am looking at LHS, he says that the LHS is a prime numbers. Okay. If you are looking at all these numbers up to here, these are your prime numbers. But 9 is not a prime number. 9 is not a prime number, and in the RHS is says that all of them are prime numbers, isn't it? So this situation is wrong over here. Okay. So let's look at the next bit. Now you need to list all the subsets. Okay, subsets of the following sets. Right? You need to remove all the subsets of your following sets. So this subsets of B are, I can write it separately. I can write this one also separately. I can even write these two combined, and also I can write a null set. Okay. So these are just subsets of B. So similarly, let us look at the subsets of C. I can write X separately. I can write Y also separately. I can also write Z also separately. And also I can write X comma Y separately, Y comma Z separately, and also Z comma X separately. And also I can write them as a group X comma Y comma Z. And also I can write null set. Okay. So that was about your C. So let's look at D. The subsets of D are A, B, C, as well as your D. I can also write them as groups like this: A comma B, B comma C, and C comma D, and what D comma A, isn't it? And D comma A, and also I can write them as different subsets. That means I can write that as here. I wrote it A, B, B, C, C, D, and C, A. I can write this also as C, A, and A. I can also write this as A, comma D. I can also write this as B, comma D. I can also write A, comma B, comma C as a whole group. I can also write B, comma C, comma D as a whole group. I can also write A, comma B, comma D as a group. I can also write A, comma C, comma D as a group. And I also can write the whole set as like this, and eventually you will be having a null set. Okay. So let us look at E. What are the possibilities of E? E, I can write here 1 I can write 4, I can write even 9, I can even write 16, and even I can write 5, right? Eventually the groups 1 comma 4, also 4 comma 1, also 4 comma 9, and also 9 comma 4. Also I can write 9 comma 16 and also 16 comma 9 and also 16 comma 9. Now eventually I can write it as a group, that is 1 comma 4 comma 9, and also I can write 4 comma 9 comma 16, and also I can write so what are the options I can write? 1, 4, 9, and I can also write 1, 4 and 16 as a group, right? And also I can write 4, 9, 16 first, and last is 1 comma 4 comma 9 comma 16. Okay. So let us look at this at number D. Sorry. So at number F. What would be your subsets here? I can write 10. I can write 100. I can also write 1000 separately. I can also write I set. I can also write 10 comma 100, and I can also write 100 comma 10, and I can also write your 100 comma 1000 separately, and also I can write 1000 comma 100 separately, and at last I can write the whole group. So this was about your subsets. I hope